So the box on page 7 summarizes what we just learned from example 3 regarding reflections. Okay, so again, I'm going to start by focusing here. If you can see where the little eraser icon here is, I'm going to focus on this and then I will return to the top part of the box. Okay, so what's going to happen is you're going to be given a basic function. Okay, it definitely could be one of the basic functions that we learned about in section 3.4, and there is going to be some kind of negative sign involved, and if there is a negative sign involved, that's indicating that there is a reflection. Okay, if the negative sign goes in front of the basic function itself. Remember here, f of x is the original function, the basic function that we're working with. If the negative sign goes in front of the basic function, that's a reflection across the x-axis. If instead the negative sign goes on the inside, so it's inside parentheses or inside a square root or inside the absolute value symbols, okay, that's going to indicate a reflection across the y-axis, okay. If you have both negatives, you have a negative on the outside and one on the inside, that's saying you're reflecting about both x and y. So ultimately, you're reflecting about the origin, okay? That's how you're going to have to recognize, that's what you have to know in order to recognize the transformation. You might have to draw it. If you're asked to draw it, if you know you're drawing an x-axis reflection or a y-axis reflection or an origin reflection, you can just use what we learned when we did symmetry. Okay, so you can see right here, points x and y and x negative y are reflections of each other across the x-axis. Okay, so basically if you're drawing x-axis symmetry, remember x will stay the same, you're just going to change the sign of the y value. Okay, so that will be helpful if you're drawing x-axis symmetry. Same thing for y-axis symmetry. If you're looking at y-axis symmetry, the rule we learned for y-axis symmetry, if you start up with a point x, y, then the y-coordinate is going to stay the same, and then you're going to change the sign of the x-coordinate to get the point that's been reflected about the y-axis, okay? Origin's not listed here, but I will write it out to the side. So remember, for origin, if you start with a point x, y, then you're going to change the sign of both coordinates. Okay, so if you have a point on your graph and you're trying to draw the point that's been reflected about the origin, you would just change the x value sign and the sign of the y value as well. Okay, so that's some handy information. Okay, let's try example 4, which will also involve reflections here. Okay, so let's read it. It says, if 3, 6 is a point on the graph of y equals f of x, which of the following points must be on the graph of y equals negative f of x? Okay, so this is a multiple choice question. You have 4 points to choose from. It may seem like an abstract question because you don't know what f of x looks like. Okay, we don't know what it is. We don't know what it looks like. We don't know what the equation is, but that's okay. We can still do this, okay? Whatever the graph is, we know that the point 3, 6 is on that graph, okay? To do this question, I recommend drawing it out because it's really visual. Okay, so I'm going to go ahead and draw an x-axis here and then a y-axis. So let me get that together. So I've got my y-axis. Let me go ahead and draw in the x-axis. Again, no clue what this graph looks like, but I know that the point 3, 6 is on the graph. Okay, so let's find that point. So 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so here's our point 3, 6. It's on the graph of this original basic function that we're dealing with, whatever it is. Okay, we want to know where that point goes if the graph of f of x is transformed in this manner. Okay, if the transformation is negative f of x, where does that point go? Okay, well, what kind of transformation is this? Okay, again, we started with f of x. We have f of x, but now we have a negative sign in front. Okay, so if you go back to your reflection rules, what does it mean when you take your original function and you just stick the negative out front? Well, it means this. Okay, this is going to be a reflection across the x-axis, okay? So that's what this is. This is a reflection over the x-axis, okay? So let's try to draw this out. If we were to fold our sheet of paper along the x-axis, okay, where is this point 3, 6 going to end up? Okay, you can also think of it with your symmetry rules. Okay, for x-axis symmetry, if you start with a point x, y, it's x-axis symmetry. So the x-coordinate is going to stay the same and the y-coordinate is going to change sign. Okay, so if you apply that logic here, where is 3, 6 going to go? Well, the x-coordinate is going to stay the same and the y-coordinate is going to change sign. Okay, and if you drew that out, that would be 3, -6. Okay, it's going to go down here. Okay, and that makes sense. Visually, if you look at this, you fold your sheet of paper along the x-axis, this yellow line, this top point, 3, 6, would fold down and lie on top of 3, -6. Okay, so again, you're seeing that whole idea with x-axis symmetry that, you know, if you start with a point, to get to the corresponding point, once you perform the transformation, the x value would stay the same. You would change the sign of the y value. So the answer here is going to be C. Okay. To do this type of problem, you had to recognize the transformation from the equation. You know, if you were starting with f of x as your basic function, and you were given the transformation, you know, negative f of x, you have to be able to recognize the type of transformation. You had to realize that this was a reflection across the x-axis, and then on top of it, you had to know how to draw it.